Welcome to the last question, number 37 of the June 2016 Algebra 2 exam. Let's go ahead and zoom in here. That's a pretty lengthy question. There's a few parts that need answered. Let's start with the beginning. So we're talking about the breakdown of a drug, and it's represented by this function here, n of t. And we know that n sub 0 represents the initial dosage, r is the decay rate, and t represents the time in hours. So for the first part of the question, we need to write two functions, a of t and b of t, to represent the breakdown of the respective drug given to each patient, and graph it. So let's start with a of t. So we start with n sub 0 being the initial dosage, and patient A is given 800 milligrams to start off. And we are multiplying that by e to the power of negative RT. And R represents the decay rate, and the decay rate for patient A is 0.347. And then we're just going to multiply that by T. And we're done. Now, B of T is going to be pretty similar, except they're given 400 milligrams to start off, and their decay rate is 0.231. And don't forget to add that little t there. Okay, so to graph these functions, obviously we're going to be utilizing your graphing calculator. You'll have to play around with your window settings quite a bit to make sure everything fits. So 0, 0 is down here, and we're going to move along intervals of 1 along the x-axis, like so. Now for the y-axis, we want to make sure we get the y-intercept for both of the functions, and you should be able to figure out that a of t is at 800. So to make sure that fits, what I'm going to do is I'm going to go up in intervals of 50, and that way we can plot the y-intercept of at. Nice there. And then let's use a dark green for the b of t. So the y-intercept of b of t is at 400. Okay, so now with your graphing calculator, you're going to be using the trace function to plot the rest of the points. So for example, for a of t, you would input an x value of 1, and you should get an output of 565. So that's going to be right around here. And then for an x value of 2, we get an output of 400. So I'm not going to bore you. You obviously know how to get the rest, so I'm just going to pause the video, and voila, the points have appeared. So let's give them a nice connection. We'll notice that they connect where x is equal to 6. They have the same point, so that's where they intersect. Here we go. So we should label these. We've got a of t and b of t. All right, now that we've got it graphed, let's move on to the next part of the question. And it says, to the nearest hour, when does the amount of the given drug remaining in patient B begin to exceed the amount of the given drug remaining in patient A? So it turns out it was a good idea to notice where they intersect. We were just saying that they intersect at where x is equal to 6. So after 6 hours, patient B starts to receive more, not receive, but there's more of the drug remaining in them, because you can see after 6 hours, B of t is higher than A of t. So we can say 6 hours. Now, moving on to the last question. It says the doctor will allow patient A to take another 800 milligram dose of the drug once only 15% of the original dose is left in the body. So we need to figure out how long that would take. So what we're going to do is we're going to use, this is a patient A, So we're going to be using the patient A formula, this one up here, and we now know the final amount, A of t, needs to be 15% of the original dose of 800. So real quick, we got to figure out what is 15% of 800, and we can do that just by taking 0.15, multiplying it by 800, and that's 120. Okay, so now using the equation, we want the final amount, 120, to equal 800 times e to the power of negative 0.347 to the power of t. So now we just need to solve for t here. I'm sorry, I'm really running out of space, but we're going to zoom in a bunch here. Now, the first thing we want to do is get rid of this coefficient of 800. We can do that just by dividing it out. And then we would be left with 0.15 equals e to the power of negative 0.347t. Now, because we have e as a base in this power and our unknown variables in the exponent, we're going to take the natural log of both sides of the equation, so ln. And by doing that, we can use that neat little trick where we take this exponent and move it over to the front. So we know that ln of 0.15 is equal to negative 0.347t multiplied by ln of e. Well, as you should know, ln of e is the same thing as 1. So we can essentially cross that out. So one step remains to get t all completely by itself. We just need to divide everything by that coefficient, negative 0.347. It's going to make that cancel out. And so we just have to do ln of 0.15 divided by negative 0.347 to solve for t. And by doing that, we get an answer of 5.5 hours rounded to the nearest tenth. All right, I believe we've answered everything, and I hope that was helpful. Thanks for visiting JD's Regents Preparation.